This formula is what we're going to be considering the old friction loss formula. The friction loss formula is friction loss is equal to 2 times q squared plus q. This old formula was used only for 2.5-inch hose, and it was based on hundreds of gallons per minute per 100 feet of 2.5. So it's what we consider the old formula. It's a pretty simple formula, so let's just say that we had 400 gallons per minute flowing. Then all we're going to do is take our friction loss is equal to 2 times the flow, and the flow is in hundreds of gallons a minute. So flow would be 400 gallons a minute, so we're going to divide that by 100. So actually Q in this formula is 4. So 2 times 4 squared, and then we're going to add it back in there of the flow divided by 100, so 4. When we do this formula out then, it's very easy to see that our friction loss is 4 squared is 16 times 2 is 32 plus 4, and our friction loss would be 36 psi per 100 foot of hose. So if we had 400 gallons a minute and 100 foot, then we would have 36 psi of friction loss. Now sometimes what they'll do with these formulas is make them a complex formula. So what they'll do is they'll give you a given of 250 feet of 2.5, and then what they'll do is they'll tell you that you have a smooth bore nozzle flowing with a 1-inch tip, and it's flowing 50 psi. So you're going to have to go back and do 2 calculations. Your first one is going to be calculating how many gallons per minute, because we need that to get our Q. So we're going to use our normal flow formula of Q is equal to 29.7 times the diameter squared. It's a 1-inch, so 1 squared times the square root of our pressure, which is 50. When we calculate that out, we have 29.7 times 1 times 1 squared is 1, and the square root of 50 is 7.07. And when we multiply that out, we know that that's flowing 209.98 or 210 gallons per minute. We now have the information to go ahead and plug into this other formula. So we're flowing over 100 gallons a minute, so we're going to use this formula. And when we put those numbers in, you're going to have your friction loss is equal to 2 times the flow divided by 100. Our flow is 210, so that's 2.1. We're going to square it, and then that's going to be add in 2.1 also to add in Q. So our friction loss is equal to 2 times, and 2.1 squared is 4.4, plus 2.1 again. Friction loss is equal to 8.8 plus 2.1, and so our friction loss is equal to 10.9 or 11 psi per 100 foot. The only problem is it's a complex problem. We've got 2.5 or 250 feet, so we're going to have to take 100 into 250, which is 2.5. So we're going to have to take our 11 psi and multiply it times 2.5 to get enough feet. And when we do that, we're going to come up with 27.25 psi of friction loss. Now when we get our 27.25 psi of friction loss in 250 feet, we know that that is rated for 200 or for a 2.5-inch hose. If we want to go with a different size than a 2.5-inch hose, the only way we're going to do that is come up with a conversion chart. And the conversion chart is going to tell us that based on different sizes of hose, we're going to either divide that number by this factor or multiply it by this factor in order to get our correct answer. It doesn't matter which one you use because you'll come up with the same answer. It's just whatever's easier for math. But that's how you would convert it for different size hoses. And then the last one is that this is all based on over 100 gallons per minute. So if, for instance, when we did this formula here, if we had less than 100 gallons a minute, we're going to change this formula slightly. So over 100 gallons a minute is friction loss is equal to 2q squared plus q. Whereas friction loss of less than 100 gallons per minute is friction loss is equal to 2q squared plus 1/2 q. So all we're going to do is in this section right here, we're still going to have the 2 times 2.1 squared plus, and then we're only going to add 1 in here. So our friction loss is actually only going to be 10 psi if we were flowing less than 100 gallons a minute.